Hey guys, I just wanted to talk about Huckel's rule and try to give you a better understanding of exactly how to use it, how to implement Huckel's rule, and you do that. Huckel's rule is basically the last step in determining if a cyclic compound is aromatic or if it doesn't fit the Huckel's rule, it is anti-aromatic. Now, when I say aromatic, what I mean is the ability for the electrons to free flow around a cyclic molecule. And in order to do that, they can't have hindrances. And so, um, the first two things you need to look at in a molecule is obviously, is it cyclic? Does it connect on it? Does it go around in a circle, connect to itself? And also, then you have to look at the conjugation of the molecule. So if it's conjugated, what that means is you have pi orbitals where the electrons, or basically double bond, single bond, double bond, single bond, or sometimes if you have an empty p orbital in the case of this molecule here. I'm not trying to confuse you. What I do want to know is I just want to clarify Huckel's rule at the end of this so you can really utilize it in the last step in determining if a compound is aromatic or anti-aromatic, or perhaps if it's non-aromatic at all, it's not even aromatic at all. So what we need to do, we'll look at benzene. So benzene is a really incredible molecule. You find it in a lot of fruits, wines, all kinds of things. It's incredible. So in the form of like phenyl OH groups attached to the ends of it. Anyways, um, so when you have a six, so let's look at benzene. Benzene has a double bond, single bond, double bond, single bond, double bond, single bond. So that's conjugated, and it's also flat. It's also planar, two-dimensional. And so benzene, you have these pi bonds, pi orbitals, sorry, and pi bonds, and they look like figure eights. And the electrons are jumping around there. And so we'll put some more figure eights over here. So pi orbitals. If I could only do the drawing justice. So the electrons are being shared in these p orbitals. They're being shared, and because each carbon has a p orbital, the electrons are able to just go through the molecule, and they call it delocalized stabilization of the electrons throughout the benzene ring. And um, so these are really not realistic. So they call them resonant structures, where you have multiple pictures that represent the molecule, and ultimately the benzene ring can be summed up with a circle in it, representing that each connection has half 1.5 pi double bonds. So, anyways, so the benzene ring is flat, 2D, it's planar, it's conjugated, and the last thing you need to look at is, does it fit Huckel's rule? And so Huckel's rule, people throw around 4n plus 2. What does that mean? I don't know what it means. So basically, or I didn't know what it means. So what it means is when you say, okay, 4n plus 2 equals, then what you do is you put in how many pi electrons or are proposed to be orbiting the molecule. So in this case, you have 1, 2, 3, 4, 5, 6 electrons orbiting 3 or 6 pi electrons orbiting the molecule. So when you put it into Huckel's rule, 4n plus 2 equals 6. The idea is you solve for n, and when you solve for n, if you get a whole number, it fits Huckel's rule, and it is aromatic. So 4n plus 2, 6 minus 2 is 4. 4 divided by 4 is 1. N equals 1. That's a whole number. So benzene can be considered aromatic. So there are other cases, though, that are not quite the same. So a classic example I've seen a few times is cyclobutadiene, and this is not the right name, but dienyl, I don't know. Anyways, whatever. So this square with two double bonds in it, it is flat, it is conjugated, double bond, single bond, double bond, and so you would think it would be aromatic. So, but when you count the pi electrons, 1, 2, 3, 4, and you say, okay, 4n plus 2 equals 4. Now when we solve for this, 4 minus 2 is 2. 2 divided by 4 is 2 over 4. Drops down to 1.5. 1 over 2. So it's 1/2. So 0.5 is not a whole number. So cyclobutadiene, or whatever this compound is called, is anti-aromatic. Anti-aromatic. Bam. So cyclobutadiene does not fit into Huckel's rule, and it's anti-aromatic. So let's look at a few other compounds to kind of get really to understand this better. So they're always throwing tricks at you, and you got to kind of be ready for it. So here in this molecule, it's just a triangle ring or whatever. Forgive me for not knowing the name. It is a propyl cyclopropyl compound. So this one, when you first look at it, you just say, is it flat? And in this case, it's not flat. And the reason is because of these 4 connections here. 4 connections means that it's sp3 hybridized. What that means is that because you have 4 connections, there's no possible way that it could be flat. It is 3-dimensional. And therefore, it is not flat. Therefore, this is non-aromatic. There we go. Okay, so this is non-aromatic. It's not 2-dimensional, so the electrons can't freely flow through the molecule. Now this one needs to have a minus sign on it. It has 2 electrons on there, a lone pair of electrons on the top. Now this guy, it's funny, you wouldn't think it, but this is actually conjugated. It's flat, and it's also conjugated. So this one, you have 1, 2, 3, 4. Right? Yeah, I think so. So let's do our rule, okay? 4n plus 2 equals 4. 4 minus 2 is 2. I don't know if I'm doing this right, but 4 minus 2 is 2. 2 over 4 is 1/2. And if that was 3, it wouldn't have worked either. So this is anti-aromatic. AA. Okay, and so this example here, for this compound, this plus means that those electrons are not there, and also that another set of electrons is also left. So this bad boy actually only has 1 hydrogen attached to it that you don't see, and carbon is upset because carbon doesn't have the connections that it wants. It only has 3. So when it has a plus sign, it means that it has a empty pi orbital, which allows these to freely flow around. And when we plug this into Huckel's rule, for n plus 2 equals 1, 2, 3. No, so that one's 2. See, okay, so there's no electrons up here, so you only have 1, 2. 2. Okay, so 2 minus 2 is 0. 0 over 4 is 0. N equals 0. That's a whole number. And therefore, this guy is aromatic. So there's tricks. They got tricks, all kinds of tricks for you. So I hope that helps. The main thing for me was just to show you how to work Huckel's rule, and I hope that you got some benefit out of this and a few other avenues. So thank you.